Good morning, our students, and welcome to this morning's discussion. Today, again, we want to start looking at other bigger time series models like the AMA models, the ARIMA models, the SARIMA models, and even other complex models in time series. And it is necessary that before we begin looking at these models, because of their complexity, it is necessary that we look at a concept that will guide us to manage the complexity of these models. And that concept is what we call the backward shift operator. Another name of calling this backward shift operator is what we call the lag operator, or what we call the lag operator in time series. So anytime you see people write this way in time series, they have what is called backward shift operator. They have something like this: backward shift operator. They normally write this backward shift operator with a capital letter, what, B. And we are saying that this backward shift operator can be called in another way, and that another way of calling a backward shift operator is to call it lag operator. Is to call it what? Lag operator. Lag operator. And then this lag operator is always written with a capital letter, what, L. So what B does is actually what the L does, but called in a different way. What actually do they do? Going by this name backward, or this word lag, we now know that it has to do with shifting the time index of a time series observation backward. So when we talk about the backward shift operator, its function in a time series is to shift the time index of a time series observation or of a time series one step backward. Let us first of all consider that we have this backward shift operator. We have this backward shift operator, what? B. And then we have a time series observation, what? Y of t. And we want to apply this backward shift operator on this time series observation collected at time t. It is going to be written as this: B y of t. So the question becomes, what is the effect of this B on this time series observation collected at time t? Its function is to shift this time index t one step backward. And then it will be written as that this is what? Y of t minus 1. So that is what this B does, the operator. It shifts the time index now one step backward. Therefore, if we have something like this, if we have something like B raised to power what? 2, which is still our backward shift operator. Then we still have a time series observation Y of t. And we are to apply this backward shift operator. It is going to be B, open a bracket, B Y of t. Because if you use this B to open a bracket, you now arrive at your square here. And we know quite alright that B of Y of t is given as a Y of t minus 1. So this is the same thing as writing what? B, the one that is outside, you open a bracket. Instead of writing this, you write this because they are the same thing. Then what you have here is what? Y of t minus 1. And you know that the function of this operator is to shift the time index now one step backward. So applying it on this place now, you are going to have that this thing becomes what? Y of t minus what? 2. And then, of course, I want us to look at something and understand something. Now, it is somebody can easily come here and write this in 1 and come here and write this in 1 because raising it to the power of 1 doesn't really change the meaning of that letter there. And then when it is raised to power 1, we can see that what we have here is t minus 1. That 1 that is raised to power here. So it's as good as saying t minus what is here. I want us to equally look at this place. What we have here is what? B raised to power 2. Okay? Which in this place, somebody can write this into be B raised to power 2 y of t. And the question becomes, when the power is 1 here, what we had was t minus 1. Now that we have 2 here, what we are going to have is what? T minus 2. And that's exactly what we have here. So conventionally, or going by that format now, it implies that if I have something like b raised to power what? 3, and I want to apply it on the time series observation y of t, it is going to be written as b raised to power what? 3 y of what? T, which now makes it now to be y of what? T minus what? 3. And then if I have it now up to the point that I have b raised to power what? K, applying it on the y of t, I will now be able to have b raised to power what? K y of what? T, which now makes it to be what? Y of t minus what? K. So that is how to apply the backward shift operator. However, we are going to look at other ways that this backward shift operator can surface or can appear. So permit me to clean here and then we show ourselves other ways of applying this backward shift operator. Permit me to clean here. So in that case, we can be given time series observation and we can be asked to put it now in a backward shift operator. For instance, if somebody gives us something like this, which we have illustrated, if something gives us what? Y of t minus 1. And the person asks us now to apply a backward shift or to write this time series observation in the form of a backward shift operator. What we are going to see is that this thing becomes what? B y of t. Because if we apply this b on this y of t, we return here. And then if we have something like what? Y of t minus 2. And we want to apply this backward shift operator or write it in form of backward shift operator, it becomes b raised to power 2 y of what? Of t. And then if we have something like what? Y of t minus what? 3, we are going to write b raised to power what? 3 y of t. And then if we have y of t minus k, it is going to be b raised to power what? K y of what? T. These are time series observations at time t minus 1, t minus 2, t minus 3 to t minus k. Writing it in the backward shift operator format, we have these. And you can see that all these things now is at time t, time t, time t, time t. And then because of the presence of the shift operator, which when applied now, will now represent the time series now in a large form, which is exactly what we have here. However, we can occasionally have something like this. We can occasionally have something like this. So permit me to clean here. We can have something like this, where we have 1 minus what? Beta, which is b of x of what? Of t. And they tell you that this thing is written in form of a backward shift operator. And they want us now to write it now in a large series. Just to write the series the way it is, applying the effect of b on the series, which is x of t here. But let me be consistent. Let me be making use of what? Y of t. but you can actually make use of x of t. If they give you something like this and you want to write the series the way it is, use this y of t to open a bracket. And it becomes y of t times 1 will give you what? Y of what? T minus, which is what you have here. Then you multiply this, which becomes what? B y of what? T. And then you now see that you are now going to apply this shift operator now on this. And to apply it on this, what you are now going to have becomes what? Y of t minus y of t minus 1. This is what you are going to see. So you have written the series the way it is now, applying the effect of what? Of the shift operator. You can equally have something like this. You can equally have something y minus what? D. You have what? Y of what? T. This is raised to power what? 2. And then you are to write the what? The series the way it is. You are going to apply this way. You have 1 minus what? B. Then 1 minus what? B. Close it now. You now have what? Y of what? T. Then you are now going to first of all open this bracket now by doing this. 1 multiplied by 1 will give you what? 1 minus. 1 times b will give you minus b minus. B times 1 will give you what? Minus what? B. Minus times minus will give you plus. B times b will give you b raised to power what? 2. You close it now. Y of what? T. It is at this point now you use this y of t to open this bracket, and what you have becomes y of t minus. Here is minus 2b. So you have minus 2b y of what? T. This is plus. Plus what? B raised to power what? 2 y of what? Of t. Then you now apply the shift operator the way it should, which becomes what? Y of t now minus. Here is 2. Applying the shift operator here, we now have y of t minus 1 plus. I equally have this shift operator to be applied here, so I have y of t minus what? 2. And by this, you have written it now in form of what? A series, the time series. But what if we are given this, and we are given this, and we are now asked now to put it back now in the form of what? A shift operator. We now come for this one, for instance. What we have here is what? We have y of t minus what? Y of t minus 1. Okay? Because this is just like factorize using the backward shift operator. So when we come here, this one remains where this is time series observation in the present time, t. So we don't have anything to do with that. Where we have something to do is time series observation in the previous. That's why we say backward shift or lagged operator. So we write this one the way it is, y of t minus. This is where we are now going to write this in this way. We have b y of t. Reason, because we know quite all right that when we apply this effect of b on this, we return here. The good news here now is that we have now y of t and we have y of t. So we can factorize y of t out, and what we have now becomes what? 1 minus what? B, close the bracket now, y of what? T, which is exactly what we had here before. So we can be given a series in this way, and we can be asked to now apply the backward shift operator in a way of writing it this way. Then when I come to this one now, of course you see how this one is. So this, you apply the effect here, you apply the effect here. And then when you apply the effect here, what you are going to have here becomes, you have y of t minus, you have 2 y of t minus 1 plus what? Y of t minus what? 2. So retaining this one the way it is, y of t minus 2b y of what? T plus. You have b raised to power 2 y of what? T. And by this, you find out that you now have y of t, y of t, y of t. You factorize. Factorizing, you open a bracket, 1 minus. You have 2b plus b raised to power what? 2. Close it now. Y of what? T. And of course, if you solve this quadratic equation now, you are going to get exactly 1 minus b all raised to power 2. So this thing becomes finally 1 minus what? B all raised to power what? 2 y of t, which is exactly what we had here before we began to expand. So what we are going to do quickly now is to look at how we can write all the models we have learned in time series now using the backward shift operator. That is, how we can write what the AR models in form of backward shift operator, write MA models in backward shift operator, and write a combination of AR and MA, which we call the AMA, using the backward shift operator. And with that, we have learned how to apply it now on our time series observations. So permit me to clean this place. You remember that by definition, the AR model, that is the autoregressive model, is a model in time series where the current observation of the series depends on the previous values of the series and then the error term. So if you are asked to write it now, this is now how to write it now. You have that y of t is given as, you have phi 1, y of t minus 1, y of t minus 1, plus phi what 2, y of t minus what 2, plus you have what phi p, you have y of t minus p, plus what a of what t. This is what we call AR of order P models. AR of order P models, where the current observation y of t depends on P previous values of the what of the series, beginning from 1 to 2 up to P, before we talk about the word the error term. So what we are going to do now is we are going to consider AR of order 1, apply lagged operator, consider AR of order 2, apply lagged operator. With that, we have learned how to use it now to write the model. If we talk about AR of order 1, we are going to stop here and then we take the error term. So we have that this is y of t is given as what? Phi 1 y of t minus 1 plus what? A of what? T. This is AR of order 1, where the current observation depends on one previous observation of the series or one previous value of what of the series. Now, we want to learn how to apply backward shift operator here. So this is going to be this way. Write y of t the way it is. So you have what? Y of t the way it is. Okay? Then first of all, bring this one that contains y of t to the other side equally. Minus what? Phi 1 y of t minus 1. This is equals to what? A of what? Of t. You don't touch the one that is on the current observation. The one you consider is the one that is a lagged value. So what are you going to do here? What you are going to do here becomes, you write this one the way it is. Y of what? Of t, then minus. Here is phi 1, you write your phi 1. You now consider, this is y of t minus 1. So it's a lagged value. You bring in the operator, then you retain the current time y of t. So you are going to have b y of what? T. This is equals to a t. Now, the reason is that if you apply the effect of this operator on this, you arrive at this. So this quantity and this quantity is the same thing. But what we are trying to achieve is where we have y of t here and we have y of t here. So it is now going to be, I factor it out, open a bracket. If I want to factor it out now, this becomes, I open a bracket, here would now be what? Be 1 minus what? Phi 1, then b, close the bracket, what? Y of what? T. This is given as what? A of what? Of t. Now, we are going to say, let this 1 minus phi 1 of b be something. We can say, let 1 minus what? Phi what? B. 1 minus phi 1b be equals what? Phi of what? Of b. Let this 1 minus phi 1 of b, which I have here, be phi of b. So it will help me to write this in a very smaller form or compact form. It becomes what? Phi of b, which is now the whole of this thing now. Y of what? T is equal to a of what? Of t. So whenever we have this kind of thing written this way, where we have information that this phi of b is the same thing as 1 minus phi 1 of b, we quickly say that that thing is AR of order 1 model. AR of order 1 model. That's why I see that this is 1 minus phi 1 of what? Of b. However, when we want to talk about AR of order 2 model, we are going to have something y of t is given as phi 1 y of t minus 1 plus phi what 2 y of t minus what 2 plus what a of t. If I want to apply the backward shift operator here, I will quickly now factorize this in this way. Bringing all of this one this side, we have y of t minus phi 1 y of t minus 1 minus phi what 2 y of t minus what 2. Then this equals what? A of t. Then as usual now, applying that b here, what I'm now going to have now will now be, we have y of what? T minus. I have phi 1, here will now be b y of t minus. Here is what? Phi what? 2. Here will now be b raised to power 2 y of what? Of t. This will now be equals to what? A of what? T. And it is at this point now that you see that what I have here is what? Y of t, y of t, y of t. So I can then factorize. By factorizing now, what I'm now going to have is open a bracket 1 minus. I have what? Phi 1 of what? B minus. Here becomes what? Phi what? 2 of what? B raised to power what? 2. Close the bracket what? Y of what? T. This equals to what? A of what? Of t. And then we know quite that we can say let everything that is in this bracket now be this. So if I do that, what I'm going to have is what? Phi of what? B y of t is equal to A of t. On the grounds that this phi of b is given as this quantity that is here. In that case now, we say that we now have AR of order 2 model. So if you have AR of order 2 model and you want to write it now using the backward shift operator, this is how to write it now on the grounds that this is equal to this. If you want to write AR of order 1 model, this is it now on the ground that this is given to be this. So you can write out of order 3, order 4, and the rest of them. Let us quickly look at now the MA models. This is the AR model. Let us look at the MA model. So permit me to clean this. You can write for 3, for 4, even up to this P. Okay, so if you want to talk about what the MA models, the MA models now is what we call the moving average models, where the current value of the series depends on the previous error terms or white noise of the series. So we have that our y of t is given as, we have what? A of t plus, we have theta 1 A of t minus 1 plus theta what? 2 A of t minus 2 plus dot dot plus we have what? Theta what? Q A of t minus what? Q. This is what we call MA of order Q model, where the current observation depends on Q error terms, previous error terms of what? Of the model, beginning from 1 to up to what? Up to Q. It's always conventional to write the coefficients of AR with phi and then the coefficient of MA with theta. So we are going to quickly look at what MA of order 1. MA of order 1 is going to be written as y of t will now be given as what? A of t plus theta 1 A of t minus 1. This is how it will be given. And because of that now, it is simple now if you want to apply that. Now here is current observation, we will not touch it. Where we have lagged value is here. So if I want to apply that now, it is going to be that I have y of t, which is what I have here, is equals. Here is a of t, I have a of t plus. I will now come here, this is now theta 1. I will apply that here, which becomes what? B a of t. The interest in AR was to get common y of t so that we can factor. The interest in MA is to get the common a of t so that we can factor. So there is no need of now bringing this thing over here. No. If you are bringing here over here, now you are mixing y of t and a of t, which of course are to be considered separately here. So here now I have a of t and I have a of t. The interest a of t minus 1. The interest is how do I do this a of t minus 1 to become a of t? It is by applying the operator b, and I'll have this. So that this thing becomes now, by way of factoring now, this thing becomes, I'll now say that this is y of t, this is y of t equals, I open a bracket. Here becomes what? 1 minus. Here becomes what? Theta 1 of what? Of b, close the bracket now, we have a of t. And by this, I have written it now in a backward shift operator. So I can say, let this thing here, let this 1 minus theta be, I can say let 1 minus what? Theta what? 1 be theta of what? Of b. So if it is like this now, I will now quickly and say, therefore, what I have now becomes what? Y of t is equals to theta of what? Of b, a of what? Of t. On the grounds that this my theta of b is 1 minus theta 1 b. The same thing applies when we have the MA of order 2 model. When we have MA of order 2 model, we have y of t is given as what? A of t plus theta 1 a of t minus 1 plus theta what? 2 a of t minus what? 2. So applying the backward shift operator here, you have that y of t is equals a of t plus, you come here, you have theta 1 b a of t plus theta 2 b raised to power 2 a of t, because here I have t minus 2. So this thing becomes that my y of t will now be given as, open a bracket, 1 plus. Okay? Sorry, I put minus here. Look at the value that is here. This is plus. So here I have what? Theta 1 of b plus here becomes what? Theta what? 2 of what? Of a b raised to power 2, close the bracket, a of t, or a of t. So this becomes y of t is given as a theta of what? B, a of t. On the grounds that this theta of b is given as this quantity. So you can write it now to any order of a MA, order 2, order 3, order 4, up to order Q. Okay? That is how to apply the backward shift operator there. And as you can see, instead of writing this thing to be this long, writing M of order 2 to be this long, it can easily be written on this very compact form, telling you that this is what MA of order 2. It is now left for you now to expand it now to be this, because you know it is a MA of order 2 model. So we now quickly look at the AMA models. So permit me to clean here. We look at the AMA models. So anywhere you are seeing them, instead of using B, they are using L, treat it as the same thing, the lagged operator. So we quickly look at the AMA model. In the AMA model now, of course, we know that the current observation of the series depends on both the previous values of the series and then the previous error terms of what? Of the series. That's the reason why we say that the AMA is a linear combination of the previous values and then the past shock, or what we call error terms. It's a combination of AR and MA models that gives rise to what we call the AMA models. Therefore, if you want to write the AMA models, it can be written somewhere somehow like this. You have what? That y, you have that y of t is given as, you have what we call, this is phi 1 y of t minus 1 plus phi what 2 y of t minus what 2 plus dot 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 plus, you have a of t, then you equally have plus, you have theta 1 a of t minus 1 plus theta what 2 a of t minus what 2 plus dot dot dot, then I can write it up to q. Let me write it up to 2q dot dot plus. You have what? Phi of what q. You have a y of t, phi of p, y of what? Of t minus what? P. So that what I have here is a complete AR of other q models. The other p models. I will now say plus. You have what? A of what? T plus theta 1 a of t minus 1 plus theta what? 2 a of t minus what? 2 plus dot 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 plus. You have now theta q a of t minus q. So this is what we call AMA PQ. AMA. A-R-M-A of P comma what? Q. AMA PQ models. Okay? Where we have order P coming from AR and order Q coming from MA. So we quickly write out now AMA 1 1, for instance. For us to write AMA 1 1, what we are going to have becomes Y. For us to write AMA 1 1, what we are going to have becomes what? Y of what T is equal. We have phi 1 y of t minus 1, then plus. We have a of t plus. We pick this one, theta 1 a of t minus 1. This is how to write AMA 1 1. This is actually AMA 1 1. And then to write it now, we are going to combine the terms that has y and combine the terms that have a. So combining the term that I have y means this one is going to come over here, and what I have here becomes y of t minus phi 1 y of t minus 1. This equals, we have a of t plus theta 1 a of t minus 1. Then we now apply backward shift operator here. We have y of t minus phi 1 b y of t. This equals, we have a of t plus, we have theta 1. We apply the backward shift operator here. We have b a of t. And you find out now that I have y of t, which can be factored. Then I have here now 1 minus phi 1 of what? Of b y of what? T. This equals, I have a of t, which can be factored. So I have what? Open the bracket 1 plus what? Theta what? 1, then of b, close the bracket now, a of what? Of t. Do remember that we call the whole of this thing the other time, we called it what? Phi of what? B. So we are still retaining this in phi of b, the whole of this thing. Then I will now write y of t. This is equals, we call the whole of this thing that time theta of b. So we have theta of what? B, where we now have what? A of what? Of t. So this is how to write what? AMA 1 1 in a backward, using the backward shift operator. Where this are phi of b now is this, and this are theta of b now is this. So that if anybody have information that this is AMA 1 1, actually you can then write the model completely up the way it is. The same thing applies when you have a AMA 2 2. If you have AMA 2 2, you know what you are going to do. You have AMA 3 3, you have what you are going to do down the line. So we have then decided to take our time now to extray the mystery or the idea behind the backward shift operator on how it can be used to simplify time series model and all of that. In our next classes, we are going to look at another important aspect that helps us now to handle the time series model in terms of computation and presentation called differencing. Because when we get to AREMA, then we now know that we are bringing in the idea of what we call integrated models. And then this integrated model now is now talking about order of differencing. That is the number of times you intend to manipulate the data in order to make the mean to be stable. You understand? Which we call the differencing. We show how we can apply backward shift operator and differencing together in a model and present it. Once we are done with this, with complete understanding now, we now venture into discussing in details the bigger time series models, AMA, AREMA, SAREMA, and the rest of them. So thank you very much for staying put. Keep connected to our channels as we keep unfolding the classes that is going to help you become a better student of time statistics.